Welcome everybody to my talk about performing database migrations without overtime. Maybe first question, can anybody in the back hear me fine? Okay, thank you. Just give me a sign if I'm not understandable anymore, then I'll try to speak louder. So before we start, let me ask a couple of questions. So by show of hands, who works on production workloads where they can not tend to lose data in production? So when the customer would get mad if you lose data. Yeah, that kind of makes sense if you're working on production workloads. Then the second question is, who makes changes to their database or to the data schema more specifically at least once a month? So you change a column, add some fields. Yeah. Okay. All right. Then who feels confident making those changes at 3 o'clock on a Friday afternoon if they have dinner plans at 6? A handful, okay. Brave people. Or very good processes. And finally, who uses copies of their productive data in their development process? So while developing, all right. And does that contain sensitive data, or is that completely? So who uses sensitive data in test environments? You're very good, very well briefed by a CISO because you should not do that. So before we continue, okay. Wow, it's super slow. Okay, let me explain who I am. I'm Pieter. I'm a cloud architect for a consultancy company in Belgium named Ordina. Throughout my career, my motto has been anything worth doing twice is worth automating, and that's something I live to. I'm interested in anything related to cloud, so the Cloud Native Computing Foundation is something that I follow quite extensively, and I was at KubeCon this year as well. And in my spare time, I'm really into old tech, so I drive and fix an old-timer like the one in the picture. And another hobby of mine is being a sound engineer, so just like in my day-to-day job, I like to understand how things work together in a complex system. So to introduce the topic of the talk, let's look at a use case example. So let's imagine you're a developer and for a social media company, and you've been tasked to, it's 2023, to make changes to your data schema from the schema that you have today on the left to the schema on the right of the screen. So you have a name and a gender, and the gender is an enum of male and female, man and woman, and you need to migrate it over to a first name, last name, and gender. So for the name field, by shouting, does somebody know how we could move from name to first name and last name, or how would you do that? Split, yeah. And split on what? Yeah, on a white space. That's a very good assumption. Now that would work for most cases, right? I'm not sure how it is in Germany, but in Belgium that would work for most cases. If you have combined last names like they have in the Netherlands, for instance, that might be a bit more tricky, but that would be a good solution. And for the gender type, you can just easily migrate from an enum, just using the string values to move to the gender. So that's an easy migration, right? So just for the sake of the example, we will actually split on the space indeed. So as any good developer, you start looking at these requirements and you determine what impact it will have on your application. You look at your front end, you look at your back end, you look at your database, you look at all of your integrations, and you investigate what changes need to be made to actually support this data scheme, because it's not just changes in your database layer or in your database schema, but that will affect the rest of your application as well. So as any good developer, you start by writing tests for this. So you write a bunch of code and write tests, write test and then the code, of course. And you validate that the changes you think you're making are actually being made by validating these tests. And we're really good developers, so we write some more tests to be absolutely sure that we covered all of the edge cases, that we covered the edge case maybe where we have no space or multiple spaces in the name. And as always, all of our tests succeed on the first go, which means that we definitely are confident that everything works and that we can continue on releasing this feature into production. So then your process of releasing to production might look like this. So you write some code, you write some unit tests, you do some manual validation by whoever requested the change in your data schema or the new feature to have a first name, last name, and a gender as a string. And then you push it into your staging environment where it will wait on the other changes that are all happening in your environment. And then once it's on your staging environment, you're ready to go to production, right? And preferably on a Friday afternoon, because we just saw that we feel confident in pushing code to production. So then you push it to production, and after 300 rows have been migrated of your 2 million users, you get this error where it says, okay, there is an issue with your migration. You get a null last name, and that's not allowed. So any ideas what went wrong here? You can shout. Yeah, exactly. So somebody might have just entered their first name, or they put a dash between their first name and their last name. At some point, your data schema actually might have been not validating that there should be a space in your name. And this is actually a good example of some things that can happen in the real world. Your data scheme evolves over time. Applications don't live in an isolation where they just have 1 month, 2 month, or 3 month life cycles where you can understand what happened with the data throughout that process. But they tend to live months, years, or even in worst cases tens of years. Hopefully not that long anymore in this age. But applications will evolve over time. Yes? This could have been one of the edge cases you could have covered in the unit test, but it's a good question. Like I explained, your data schema evolves over time, and the issue, and the reason why you would have not have covered it, because you're working on your unit test in the assumption that your data looks like the schema that you have today. So in name, we expect first name and last name to be present, and you write test in the assumption that that's there. If you have really good testers, and I had one in my project, my last project, they will try to do anything, even if it doesn't validate according to the current scheme. But yeah, it's something you could have caught, but often is not caught if you don't know the history of the data. For example, one of the things, and I'll show that in a later example, is that the migration that you didn't know of before is that you migrated from nickname to name. And for a nickname, typically, we don't allow spaces explicitly because we use it as a unique key. And that's something that you didn't know that if you only look at the current data schema. If you look at the current one, you only see there's a name and a gender. And the assumption is that in a name, there's always a space between first and last name. So especially with rapid development that we do today, where we release every couple of weeks or even multiple times a day, it can become really hard to understand what the history was of that data schema and what your data in your production database actually looks like, because that's the side effect. If your migration, 10 migrations ago, your data changed from nickname to name, but you didn't validate there that there's a space in the name, then your assumptions beyond that point will always be wrong about what data lives in your production database. And one of the things that we tend to do is indeed write tests. And even if we double the amount of tests or even triple the amount of unit tests that we write, which is maybe a bad metric in itself, but if we even if we do that, if we're working under the wrong assumptions about how our data looks in production, then we can write maybe even 10 times as much unit tests or functional tests or system tests on synthetic data and still not uncover that issue, because we make an assumption about how the data looks, which is not valid for our production database. So this graph shows that we introduce most bugs on the left side where we actually code, and there is exactly the point where it's also the easiest to fix the issues. So that's why the shift left methodology, where we push as much of the testing to the left, and we want to find as much defects as we can on the left side, comes from, because there you're in the context of development, you just change one line of code, you run your test, and you see that something fails, then it's highly likely that you made a mistake in the one line of code you just changed. The more we go to the right, the harder it becomes to not only figure out what is broken or what is wrong with your code, but it's also way more expensive. It's a hockey stick. So it's way more expensive to fix that issue, because if you find it in development, you change that one line of code, you push your code again, and there is almost zero time loss. If you're already in the phase where you are functionally testing, so your component has been released, or even in system testing, that process becomes harder because you have to hotfix that or patch that somehow and get that into the release train. Not to mention if that happens in production, then it's really hard and really expensive, because you need now an emergency change to quickly push that change into production, and you might have impact on your end users. Data might have been corrupted in the database. There's many horror stories about that online, where people ran incorrect migration scripts on their production database, and then figured out later that hopefully they see that it breaks, because then they can immediately fix it. But sometimes it takes months or even years before they figure out that some migration somewhere went wrong. So this is the schema that I mentioned earlier. So we were working under the assumption that we were on the left side of the screen. So in this scenario, where we have a first name and last name inside the name field and a gender, and that we migrate from v1 to v2, where we just split on the space and we copy over the gender. What could have happened, or what in this scenario actually happened, is that the previous data migrations, or data schema, actually contained nickname instead of name, and we migrated from nickname to name, where we just copied over, because that makes sense, right? You go from nickname to name, you just change the name of your table column, and that's it. But what we didn't take into account there is that we make new assumptions on just having that name field. A nickname, we assume that there is no spaces. We can make assumptions that there will be numbers or dashes or weird characters in the nickname. In a name field for a social media application, we don't expect that. Then when we migrate from v1 to v2, then that becomes really hard, right? To determine what should be the first name, what should be the last name, and especially if we allow the null type to be in the gender, then what would we put here? So one of the solutions that you can do is copy over your production data. We saw that earlier in the question round. That's something that people do. They copy over production data to test systems explicitly for this reason, right? Then you can validate your assumptions that you have on your data schema. If your data schema evolved over time, you can now check that it's actually what you expect it to be. And if your migration runs against this copy and fails, then you know exactly which line failed, why it failed, and you can fix it before it goes to production. Now there's a couple of issues with doing this. The first issue is that if you go beyond a certain size, especially for relational data, this becomes quite hard to do. Copying tens of gigabytes or even hundreds of gigabytes of data, especially relational database data, is hard. It takes time. Secondly, and that's something that's often forgotten, is there are requirements on your production system for a reason. The reason that you have heavy security on your production system, and that not every developer can just look into production, or should not look into production directly, is because there are requirements on viewing sensitive data, especially with the new guidelines or regulations on GDPR, where it's not allowed to just have personalized information in any database and have allow everybody to have access. It becomes hard to copy that data because you don't only have the technical requirement to copy that data, but you also have the requirement to make any sensitive data, and especially personal identifiable information, anonymized in that database. Because your developer, by design, has access and deep access into your test and development systems, but they, at least for GDPR compliant systems, they should not have that same access in production. If you would just copy without anonymization and allow the test system to be used, then you should put the same requirements or the same safeguards in place that you have on production on your test system, negating the whole idea of using it as a test system. Something that goes hand in hand with the data copy is that it's time consuming to copy over all that data, especially if you want to get a snapshot of multiple databases, or you need a relational database and maybe some backend storage and some object storage somewhere. it takes time and it is hard. And anything that is hard and takes time costs a lot of money, which means that the requirement to be able to do this becomes a business case. You need to be able to tell the business or tell your employer, okay, we have this risk when we run this migration. We can solve it, but it costs a lot of money. Just counting, if you look at this example, just counting the infrastructure cost, it runs from $1,000 if you do it really manually, and you add your you do it really manually, and you just copy over the data into a plain VM running some database. This is an example of 100 gigabytes of Postgres data that you try to copy. You're running $1,000 at least a month in infrastructure cost, not even counting the amount of hours that the developer or any operations person has to spend on pulling the data from production, copying it to your test system, and doing that over and over again for every single test they want to run. Of course, like any cloud provider, and this is an example for AWS, but all the major cloud providers have this, you can move to managed service, which takes away the burden for your developers a bit, but it gets exponentially more expensive. If you do the RDS clone option, where you can just request a clone directly from AWS, they will happily supply you with one, but it's almost 5 times as expensive as the do-it-yourself option. And one of the things I want to stress here is that you want to solve this problem. You want to test your migrations or actually any software changes that you make, just like you test your software changes and you validate that your application code is functionally correct. You want to do that same thing for your database changes or your data schema changes or actually your application changes as well. So automation here is key. If you can automate all of this, the cost for the developer goes down, but also the infrastructure cost might go down because you just run it for a couple of hours instead of having it up for 24/7. One of the solutions you can use for this is Database Lab Engine by Postgres.ai. This is a solution for just Postgres databases and just for relational data by design. And what it does, it's a system that allows you to make copies of production data or any database essentially, as long as it's a Postgres database, into the engine, and then the engine intelligently or automatically can create what they call thin clones of that database. So instead of copying hundreds of gigabytes and spending hours and hours and hours or even days, in case you're on Azure, true story, they spend days. You can now do this in under 10 seconds for systems up to 2 terabytes of Postgres data, which is really fast and a lot of Postgres data. If you have that much, by show of hands, does anybody have databases up to the size of terabytes of Postgres data or beyond? Okay, 1 or 2. So this system, for up to 2 terabytes, they are super fast. Beyond 2 terabytes, it becomes a bit harder, but it's I'll explain that when we get to the technical details. And what they allow you to do is actually create a thin clone, which acts and looks, smells, feels like a full Postgres database with all the data inside. And it will react and respond like a normal Postgres database, but there's some trickery behind the scenes. But of course, they cannot copy 2 terabytes of data in 10 seconds. But they do some trickery to actually make it look like they do. It's a fully functional database. You can just hook it up to any system that you use or application that uses a database, and it will respond just like, or it will look and feel like a normal database. So then you can change your automation process or your release process to look like this, where you, just before you go to production, actually pull a copy from production, run your migration or your application code against the new version of your software, and actually validate that it succeeds. Which means that if our migration would have failed like we saw before because we didn't have a space in the name field, it will now fail on this environment. It will now fail here, meaning that production is not affected, and again, your end users will be happy that you didn't bring down production at 3 o'clock on a Friday afternoon, and your developers will be happy as well. Business might not be happy that you didn't release the feature, but at least you didn't break production. So I'll still take that as a win. A nice added benefit of this solution is that it also works in development environments. So we saw earlier that people also use productive data in development environments. So for instance, this is a very simple example of how you would have a development environment. Your developer has a laptop, they connect to a Kubernetes cluster, and inside that Kubernetes cluster there are services running that connect to a Postgres database. The database can be running inside the cluster, or can be outside of the cluster. That's not really relevant. And you can just replace, again, that database with that thin clone. So then your developer, during their development process, can actually use production data without having to, one, have the infrastructure to support that production data, and secondly, and this is a really nice feature in the engine, you can actually anonymize the data on the fly. Meaning that the moment that the data enters from your production database into your engine, in the database lab engine, you can run anonymization scripts or hide sensitive data or remove sensitive data from the database. And once developers now request these thin clones, so these components that they can hook up to their application, they will actually have that anonymized data. This was one of the key features that we used at the customer where we implemented this, to make sure that audit and compliance was happy with using the solution, because still we're using production data on a development system. There's a lot of checks and balances you need to pass for that. And one of the reasons that we could use it was that we could supply anonymization scripts and make sure that sensitive data never ended up on a test system, so that one of our developers could not look up how much their favorite footballer made in a year. So that's something you can do in flight, and you don't have to do offline. So now I will attempt the demo gods. Yeah, I will show a quick demo of this in use. I'll try a live demo. If it fails, I have a backup video. So let's see. So this is our production database. It runs on Azure. Apologies for that. And if we look at what data we have there, we have 10,000 rows of user data, and if you look at the user data, it looks exactly like we saw in the example. So we have a first name, it's a hash, but first name, last name, and the gender. So this is the normal production database you would have. It now runs on Azure, can be RDS, can be on-premise somewhere that you host it yourself. So this is just any old Postgres relational database. Now let's imagine that I'm a developer, I want to use a thin clone in my development environment, and I want to start developing my new feature. Then I simply go to the database lab UI, make it a bit bigger. And I can simply request a new clone. So this clone will always be based on a snapshot. I will explain if we have time later on how the snapshotting actually works. But what it essentially does is it makes a point-in-time snapshot of the data, supplies that to the developers, and if you have multiple snapshots, you can actually choose which ones you want. Do you want the latest, like we have here, or maybe you want one that's a bit in the past, because you want to look at how the data looked before a migration ran or after a migration ran. At the customer where we implemented this, we actually made nightly snapshots so that they could look at data which was maximum 24 hours old. So we create the database, or request a thin clone. Everything went well, so it's under 2 seconds. So now we have a new Postgres database spun up on our database lab engine system. It's just a plain VM on Azure in this case, and we can connect to it using either our favorite database client, or you could use this in your application or in your development workflow, or use it locally on your laptop when you connect your spin up your application and want to run some tests on that. Quick side note: you can run multiple clones, of course, on a single system. Yes. Yeah. Ah, no, this is Azure Data Studio. It's yeah, I think it's something they wrote on top of VS Code or next to VS Code. Yeah. It looks a bit nicer than PGAdmin. That's why I use it. So here we have that same database, so DB Lab demo. If I query that now with the same queries as we did before, users, no, not select star account. If we do the same queries now, we will see that we still have our 10,000 rows and our data looks exactly the same. So now let's imagine that I run my migration script. I make changes to my application. I run the migration script. Insert into users. Talking and typing is too hard. No. So if I now insert this record into my test database and I run the queries again, I'll see that I now have 10,001 rows inside my database. And if I search for the records, yeah, we get that record back. If we do the same thing, of course, on our productive database, just to show you that I'm not doing any foolery, that record is not on a production database, of course. We still have the 10,000 records there. So there were no changes to the production database. We only changed our thin clone in our development environment. Now let's imagine that our developer ran his migration and he isn't as good as we are and he made a mistake. So he wants to redo this all again. So then he goes back to database lab engine and he says, okay, I want to reset my clone. So again, instead of having to copy over data again, waiting for multiple minutes or even multiple hours or days for that data to be copied, he just goes into the engine, he resets it, he resets the thin clone, which in essence, in the background, it just recreates a thin clone. It throws away the old one, creates the new one, and just reuses the same parameters. Then we need to connect back to our clone. And if I run the queries again, and on the correct database, if I run the queries again, we again have the 10,000 rows. So the changes we made, the changes our migration or our failed migration made, are gone again, and I can restart my development process. So it's as easy as just requesting a clone, connecting to it, using it in your application, and just as fast as you run tests or validate your changes in your IDE, you can request actually production data copies for your during your development process as fast as you're running your tests in IntelliJ or in Eclipse. All right. Then to wrap up, how can you use this? There's a couple of ways you can use this. The easiest way is to start with their template on AWS. They have a CloudFormation template. You can just select in the marketplace, deploy it. Just supply what database you want it to connect to, and then immediately it spins up all the required things you need for deploying this in your environment. You can actually host it yourself as well. So it's just a Docker container that you need to run on some VM or in some system. It doesn't support Kubernetes yet. They are working on that. There's a reason it's not supported yet, but they're working on that, and hopefully they will do that soon. And then finally, how should you use this? Not just Database Lab Engine, but how should you test your data migrations? Yeah, you should automate this. So make sure that you have a workflow or some CI/CD process that actually does this in line. Make sure that your data migrations work by actually testing that they work. And don't do that on production systems. Because if your migration fails halfway through, then probably you will have a very bad weekend fixing that, requesting recovery of your database, or maybe even a snapshot of your database to be put back into production. having angry operations people shouting at you why you ran bad code on their database. So if you automate this, make this part of your process to actually validate, just like we validate code and validate our application, validate that your database schema changes or any data changes you will have in your database or migrations, that those work, make sure to automate that as well. Because even if you use a system like Database Lab Engine or any other system that allows you to do this, if you don't automate it, people will bypass it, people will skip it in their as a manual step, because there's pressure to release or there's pressure to not do it, or because they just don't want to do it. So if you automate it and make it part of your release train, there is no other way than actually to do it. Are there any questions? Or I will take questions now. Yeah.
Why did you use hashes for the first and last?
It's just a demo, so that I could easily generate 10,000 records. Yeah. No. Yeah. It's not because I'm lazy. Yeah. Yes.
There is an API integration to integrate with test.
There is a Database Lab Engine itself as a REST API, so you can just speak. So the web front end speaks to the REST API backend, so you can integrate it in JUnit directly, or you could use it like we did in a CI/CD pipeline. There's even a CLI that you can use directly. So yeah, there's a REST API where you can integrate this easily. Not directly in Java, but yeah, you should just call it a REST API then. Yeah, this one only works for Postgres, but the ID works for everything, of course, but the engine only works for Postgres. Yes. Yes. They have a couple of options. The easiest is that you just supply SQL scripts. So you just supply the SQL code. What we did at the customer is we supplied for every column that we wanted anonymized, we supplied a SQL script that just removed all of the references. Another thing they support, which is, if I recall correctly, a normal or a regular Postgres extension, is the anonymize extension, where you can just tell in comments or in your data scheme definition that this is a column that contains sensitive data, and then in the process of making the snapshot, you can actually just call anonymize as a function in Postgres, and it will anonymize all of the data in your database in one go. So that's something that we tested as well, but we didn't use. Any other questions? All right, since we have a couple of minutes left, for those who are interested, what we learned on this journey. One is that this comes at an increased cost, of course. You have to have additional infrastructure for this. You have to have people that maintain the system, make sure that those copies are created correctly, and you need to convince your stakeholders to invest there. If you don't have the issue or don't have the regulatory requirement not to do this, then that becomes a really hard business case. If you have that requirement, especially in financial services, especially in medical or life science projects, this is a lot easier to sell. Secondly, and this is something that we at first didn't really realize, is that this only works if you automate it. If you supply it as a tool, only the early adopters in your project will use it. It's only at the point where you start not only pulling it into your workflow and making it part of your regular release process that it starts to be used a lot. That's even the point, for us at least, where developers started actively using it in their development environments as well, because they saw how easy it was to be used inside the automation, because it was all automated. They also made the step of investing in it to use it in their development environments, and they actually automated most of the tests that they ran inside the automation to be ran locally while they were developing as well. And then finally, and that's probably the most important, is get the correct stakeholder buy-in. So not only your security and audit team should be involved in this, in implementing this, also your developers on how they use it, why they would use it, and when they would use it. Because making sure that the system is used, it's a non-significant cost, even if you use the more automated way of doing it, it's a non-significant cost that you need to invest, and the system also needs to be maintained. So that's something that you need to get buy-in from your developers and your other stakeholders as well, to make sure that the system isn't put in place and then people start asking nasty questions on why and how, and you need to pull it down. So that's better to do that up front. And then really finally, how does it work? I was expecting the question, to be honest, but I'll explain it anyway. It's actually super simple on the hood, or the concept is super simple. The copy of the production database ends up in the engine, and the engine actually stores it on a ZFS file system. Who knows ZFS? Okay, a handful, then I will explain. ZFS is just a normal file system with a very useful feature, namely copy on write, which means that you can create copies of your disk supply, or make copies of your disk in seconds, where it only copies the references. So you create a new disk from your main disk, and it acts as if it's a full disk, and that's where the magic happens, of course. The Postgres container, it's a Docker container, the thin clone connects then to that snapshotted or that fake ZFS file system, and thinks it's connected to the actual real 2 terabyte disk with all the information that was on the original one. Which means that you only have to copy the references, and when you write to the disk, only then the changes are persisted on the actual new disk. All the other references, when you read 2 terabytes of data, all of that data is read from the original file system. It's not read from your copy. And that's why they can make thin clones in under 10 seconds, even for 2 terabytes worth of Postgres data, because they just use the copy on write feature and create a disk that's then connected to a Docker container that runs your Postgres database. Sorry? Yeah, it's similar to Git branching, with that difference that you cannot write back to your original disk. But yeah, exactly. So that's how they work underneath the hood, and the Postgres databases that you actually run against, so the thin clones, those are just Docker containers running on, like I mentioned, on a VM. So there's no real magic there as well. All right, with that, thank you for your time, and if you want to see the live demo or have questions, just come up to me in the hallway, and I happily explain some more. Thank you.